So far this chapter, we've been talking a lot about exponents, and we've talked about applications of exponential functions, how we can graph exponential functions and use that graph to solve for certain things. Today we are going to be moving along with logarithmic functions and what those are. So just as a quick review, slash as an introduction to logarithms, we are going to go ahead and graph the function f of x equals 2 to the x, and then we are going to graph the inverse function. So let's go ahead and start with f of x equals 2 to the x. We are going to come up with a table. When x is 0, 2 to the 0 is 1. When x is 1, 2 to the first is 2. When x is 2, 2 to the second is 4. We put in 2 to the third, we get 8. Put in a negative, we have 2 to the negative first. Remember that's equal to 1 over 2 to the first, which is 1/2. Now remember, with inverse functions, we did a little bit of this in previous chapters. Inverse functions are functions that are simply where the input and the output are switched. So if we have a table of values for f of x, then the table of values for f inverse of x is simply going to be switching the x and y values. So the first one there is going to be 1, 0, next one is 2, 1, then 4, 2, then 8, 3, then 1/2, negative 1. Now let's go ahead and graph these so we can see what they look like. So 2 to the x, we put in 0, 1, 1, 2, 2, 4, 3, 8, and then negative 1, 1/2. And there's the exponential function. Okay, and then we have f inverse of x. So we have 1, 0, 2, 1, 4, 2, 8, 3, and 1/2, negative 1. And there's our inverse function. So as you may remember from when we were talking about inverse functions, functions and inverse functions, they have a relationship in which you have, let's say you were drawing in the line y equals x, then one function is simply reflected in that line y equals x to get the other. So logarithms are the inverse functions of exponentials. In other words, taking the logarithm of a number is the opposite operation of raising that number to a power. Like how squaring a number and taking the square root of a number are opposite operations. Now there are two main types of logarithms that we commonly work with. There are obviously more than these, but these are the ones that are used most often. So the first is what we call common log, and that has base 10. That means you're working with 10 to a power. And then there's natural log, which is base e, which means you're working with e to a power. Now when we talk about logarithms though, we're not going to be writing them in the form 10 to some power equals something on the other side, or e to a power equals something on the other side. Instead, we are going to use notation involving log. So let's start with common log. So the inverse function of the exponential function f of x equals 10 to the x is called the common logarithmic function. We say that common log has base 10, so you can write it one of two ways. You can either write log of v equals u, or you can write the 10 in and write log base 10 of v equals u. Sort of similar to the square root function. If you don't write the 2, right, then it's implied that it's a square root. But for anything else, you have to write a number. So if it's a cube root, you have to write the 3 in there. Same with logs. If you don't write log with some numbered base, it's assumed that it's log base 10. Okay, so what you have in the first box there is equivalent to what you have in the second box there. So these are two different ways of writing it. So 10 to the u is equal to v can be written in terms of logs as log base 10 of v is equal to u. So let's go ahead and take a look at example 1. We have log of 1000. If it helps, you can write the 10 in. What I like to say to myself as I'm trying to evaluate this logarithm is I ask myself, okay, so the base is 10. So 10 to what power is equal to 1,000? So generally, if that's helpful for you, you can write it out, or you can just use that to help you remember how you can ask yourself a question in order to evaluate this. So 10 to what power is 1,000? Well, is it 10 to the first? Definitely not. 10 squared is 100. 10 to the third is 1,000. So 10 to the third power is equal to 1,000. So our answer here is 3. Okay, let's look at the second one. Log of 1. So again, if it helps you, write the 10 in. And also, if it helps you, try translating it into words. So 10 to what power is equal to 1? Okay, in this case, 10 to what is equal to 1? Well, 10 to the 0 is equal to 1. So our answer here is going to be 0. Now, because you know that anything to the 0 power is equal to 1, anytime you take the log, no matter what base it is, if you take the log of 1, it's always going to equal 0, the same way that anything to the 0 power is equal to 1. All right, let's look at another. We have log of the square root of 10. Okay, put the 10 in there. So now you're asking yourself, 10 to what power is equal to the square root of 10? Now, is there another way to write the square root of 10 that we've looked at recently? When we talked about radicals, we talked about how we can write that with rational exponents, right? So the square root of 10 we can write as 10 to the 1/2. So 10 to what power is the square root of 10? That's 1/2. So our answer here is 1/2. All right, last one. We have log of -3. Put the 10 in if you want to. Translate this for yourself. You're asking yourself 10 to what power is equal to -3? Now, you can think of this also in terms of the graph of 10 to the x, right? 10 to what is going to give you -3. Now, if you remember with the exponential function, remember how the y value never went below the x-axis, right? It was always positive. So how would you answer this? 10 to what power is -3? Well, it can't ever equal a negative number. So if that's the case, then there is no solution. So you can say that log base 10 of -3 is undefined. All right, let's look at example 2. Writing an equivalent statement without using log. Okay, so for these problems, this is really just to get you acclimated with going from one form to another. You're not necessarily solving for anything here. Sometimes it can help you solve by writing an equivalent statement. So in the first one, we have log base 10 of 100 equals 2. So we want to rewrite this as an equivalent statement. So one of those two boxes, we have the left-hand side box right now. We want to write it in the form of the right-hand side box, which is in exponent form. So let's write it with the 10 in there to help us. And this is the same as 10 to the second is equal to 100. So that's all you're doing here. Okay, let's do the same thing with the next one. Log of the cube root of 10 is equal to 1/3. Again, let's just rewrite it. So we're in exponential form. So I wrote the 10 in there. So this means 10 to the 1/3 equals the cube root of 10. Let's go ahead and go over natural log. So everything we've done up to this point has been common log. So for natural logarithms, the inverse function of the exponential function f of x equals e to the x is called the natural log function. We say that natural log has base e. Now if you remember, e is kind of like pi in that it's an irrational number that continues on forever, cannot be rewritten in the form of a rational number, right? Cannot be written as a ratio of two integers. Okay, so the way we write natural log is we write ln, okay, that's not an I, that's an L, so ln of v equals u. Again, if it's helpful for you, you can write that e in. It's not necessary, it's implied if you see ln that it's base e. So ln of v equal to u is equivalent to e to the u equals v. Okay, so let's do some examples similar so that we can get used to using natural logs as well. So the first one here, ln of e, again, if it's helpful for you, write the tiny little e down there and translate it for yourself. E to what power is equal to e? So e to what power gives u back itself? It must be 1. So ln of e is equal to 1. And we will end up using this piece of information quite a bit once we get into applications. And once we get into solving equations, we'll have to use this fact. So get used to knowing that ln of e is equal to 1. Okay, next we have ln of 1. So again, write the little e in there and translate it for yourself. E to what power is equal to 1? Well, we actually talked about this earlier. Anything to the 0 power is equal to 1. So similarly, ln of 1 is always equal to 0. So our answer here is 0. Okay, take a look at the next one. This one says ln of 0.15. Now, this one's a little bit trickier. You can write the little e in there. You're really asking yourself, e to what power is equal to 0.15? Now, since we know what e is, but because it is an irrational number, it's going to be very difficult for us to actually determine what that is. So we are actually going to need to use our calculator. Okay, so here's the calculator. And we want to find ln of 0.15. Now again, remember the e down at the bottom is not necessary, but it can be helpful. Now, if you're looking for the ln button, it's right under the log button. It's next to the 4 over here. So ln of 0.15, and then hit enter. So it comes out to be about negative 1.8971 or so. Now you can always check your answer by actually using that as a power. And you can try to check that e to the negative 1.8971 is in fact 0.15. Now because we are doing a little bit of rounding, it's not going to come out to exactly 0.15, but it should be very, very close. So we can take a look at that. So access the e again. Remember, to access the e, you have to hit second and then divide. And then you're going to raise that to the negative 1.8971. Hit enter. And you can see it doesn't come out to exactly 0.15, but it's very, very close. And again, the reason it doesn't come out to exactly 0.15 is because we have rounded, right? It's not exactly negative 1.8971. There are more decimals after that. Okay, let's go ahead and look at the next one. We have ln of 186. So similarly, you could ask yourself, e to what power is equal to 186? But again, this is probably going to require you to use a calculator. So let's bring the calculator out again, and let's go ahead and find ln of 186. And it looks like it comes out to be about 5.2257. And again, you can check your answer by trying e to the 5.2257 and see if it comes out to be pretty close to 186. And you can see it's not exactly 186, but it's very, very close to it, which is great. Okay, Let's take a look at example 4. We have ln of e to the third equals x. Okay, we want to get x by itself. We want to know what x is equal to. So one thing you can do here is we can first start by writing the little e in there. And then what I'm going to do now is I'm going to rewrite this in exponential form. So in exponential form, that's e to the x equals e to the third. So now you can see, since we have the same base on both sides, that x must be equal to 3. All right, let's look at another example. E to the x equals 5. Okay, so how do you solve this? Well, we're going to solve it by using an equivalent statement. So we're going to, in fact, write this in the form of natural log. Why natural log and not common log? Well, because our base here is e. So let's rewrite this in log form. So this will be ln of 5 equals x. If it helps you, go ahead and write that e in there. And then now we can just use the calculator to find ln of 5. And it looks like it comes out to be about 1.6094. Okay, we have one last example. Find the value of 10 to the log of 1,000. Now, this looks complicated because that log of 1,000 is in the exponent. But actually, didn't we already find what the log of 1,000 is? Remember, if you just see log, it means that it's implied that it's common log. So log of 1,000, I think we did this earlier, is equal to 3. So we can simplify the exponent to just be 3. So this is equal to 10 to the third. Now what is 10 to the third? 10 to the third is equal to 1,000. And you'll notice if you compare the answer here to the original expression, you'll notice this is exactly what you were taking the log of before. We'll go more into detail about very specific instances, specific rules that apply when you're working with both exponents and logs in the same expression. But do notice that if you have 10 raised to the common log of a number, it does in fact always come out to be that number you're taking the log of inside the exponent.